Have you ever wondered why the Earth looks the way it does today? How did the continents come to be scattered across the globe in their current formation? This, my friends, is a story that began over 300 million years ago. A story about movement, about the dance of the continents. This is the story of continental drift. Picture the Earth, not as it is today, but as it was in the distant past. The landmass was once a supercontinent known as Pangaea, a monolithic landmass encompassing all of today's continents. But over time, something extraordinary happened. Pangaea began to break apart, and the continents began to drift away from each other. But how did this happen? The answer lies deep within the Earth, in the molten core and the mantle that surrounds it. The heat from the core causes the mantle to convect, to move in a circular motion. This movement of the mantle causes the Earth's crust, the outermost layer where we live, to move and shift. This movement is what we call plate tectonics, and it's the engine that drives continental drift. The continents you see are not static. They are constantly moving, albeit at a pace so slow that it's almost imperceptible in our short human lifespans. But over millions of years, these small movements add up, and the continents drift across the globe. But how do we know this? Well, the evidence is all around us if we know where to look. One of the most compelling pieces of evidence is the similar plant and animal fossils found on different continents, suggesting that these continents were once connected. Additionally, the jigsaw puzzle-like fit of some continents, such as South America and Africa, is a strong visual clue of continental drift. So, what have we learned today? We've learned that the Earth's continents were once part of a supercontinent called Pangaea. We've learned that heat from the Earth's core causes the mantle to convect, which in turn drives the movement of the Earth's crust, a process known as plate tectonics. This movement of the Earth's crust is what causes continents to drift, and we've seen that evidence for continental drift is all around us, in the form of similar fossils found on different continents and the way some continents seem to fit together like pieces of a puzzle. Continental drift is a fascinating topic, isn't it? It's a reminder that our planet is constantly changing, constantly evolving, and that we, as its inhabitants, are along for the ride. So the next time you look at a map, remember that the Earth beneath our feet is far from static. It's a dynamic, ever-changing world, and we're just beginning to understand its mysteries.